Well, thank you. So I see everyone is ready for this. Thank you for inviting me for this presentation. I'm sure you heard a lot of data today, and I was announced with a magic process, but I'm convinced of the fact that we all together have that in us to find the magic way out to dissolve literally the asbestos fibers. Because you see, that's what we are doing from Asbeter in the Netherlands with the AC minerals process. We make asbestos fibers disappear. That sounds kind of magic, but do you have my, can you hear me now? Not at the moment? No sound. Shall I wait till you fix that? I'll wait till you give me a signal that you can hear me. Oh, really? You can? Oh, okay. Well, shall I go on then? Thanks. Um, let's back to the beginning. You see that we from the Netherlands developed a process which says that we make asbestos fibers disappear, and that sounds kind of magic. But in fact, we developed an alkaline process that completely dissolves the asbestos fibers, and that gives us the opportunity to recover all the material from the roof plates and the asbestos cement tubes. And we recover that in a carbon neutral way and bring it back to the origin, to the cement and concrete sector. I think I don't have much to say about this. You're fully aware of the asbestos health risks and the problems we are still facing in the EU, in the UK. Millions of tons of asbestos cement with all risk for people in the livelihood and in their jobs. And why are we bringing this material to landfill sites? Because they are contaminated for 5 to 15%. Other European member states are facing the problem of having no landfill capacity anymore. So that's a second problem which comes to it. And finally, we can say now this problem comes to an end because soon it will be no longer necessary to bring it to landfill sites. Our circular solution is bringing three problems together in one solution. And there is a shortage of raw materials in the cement and concrete sector. There is a huge pressure on bringing CO2 neutral materials to the market. And we all are facing the problem of the asbestos cement in our livelihood. To tell you more about what we are doing, well, we all know about the asbestos fibers, the chrysotile and the amphibole, and the chrysotile fibers. We start pre-treating the material, the asbestos roof plates and the piping by several steps of shredding and milling. And we engineer that in a totally closed system because all of you, just like us, are fully aware of the risks of asbestos dust. So we don't create any dust, we keep it inside, and we have our measurements for this. As soon as possible, we add water to the material, and then the chemical reaction will start. And it will start because together with temperature, low temperature below 100 degrees, and water, and the material of the asbestos cement itself, there's an alkaline environment created. And that alkaline environment, that's not what asbestos fibers do like. So they are dissolving in that alkaline environment. We need several steps to do this. And in fact, it will take really several hours to come to the conclusion that all the asbestos fibers are gone, but it's really possible. In the end, we have an extra fine milling step, an additional step to accelerate the chemical reaction. And then we are sure that all the asbestos fibers are gone. Our end product is a calcium silicate hydrate, and it's also possible to carbonate this material, because it's a mineral material and it's very easy to take up CO2. Looking at the pictures, you know these pictures, of course, the chrysotile and the chrysotile fibers and the SEM analyzing we are doing with the material we are taking in. You know the typical peak of the chrysotile asbestos, of course. This is maybe new for you. In the end, we only have some silicate clouds, calcium silicates and calcium carbonates. We thoroughly examine this by external SEM analyzing. For this, we prepare the samples, we dry them, we ask them to research more than 40 images, and only if the conclusion is no fibers are present, then we will release this as end material. And we do this at pilot scale at the moment. Last April, Det Norske Veritas did a verification of our process, and all the steps were controlled, all the analyzing was controlled, and we received the verification statement that we really ended up with a zero fiber end material. And you can imagine that we are a little bit proud on this result. From the Environmental Protection Agency, we received the end of waste declaration for our end products, which make it possible to go on with the interested market parties in the zero carbon material we deliver to do research and testing for all the applications they are interested in. In fact, this is the value chain you can consider. Also for the UK, you have an income in the front and an income in the end. In the front, you have an intake fee, and in the end, you have a fee for selling the products to the market. And altogether, what we know now is that the whole process will need a 400 euros a ton, which we can earn in the front and in the back, at the back. So there are a lot of market opportunities, of course. Landfill is the most used way to get rid of asbestos fibers, but it's also a worse solution, of course. Prices for landfilling are going up. In fact, the material is still going to contaminate the environment, to water, to air, to soil. In the Netherlands, we are aware of a policy. In fact, it's a European policy which says if there is coming to the market a safe solution for a hazardous material, then the policymakers can consider a ban on landfilling that material. They already did this for batteries, for example, for mercury. And in the Netherlands, they also wrote this down for the asbestos cement. And in fact, we are at the step of applying for the ban on landfilling, in which we can mention the typical asbestos streams we can receive and can process. And for us, that's the asbestos cement roof plate, the asbestos cement pipes, and the asbestos calcium insulation scales. There are also it's also interesting for investors to know that we are not only solving the asbestos problem, but that we in fact contribute to a circular economy. And if you're looking to the potential of the market worldwide, you see there's a huge potential. Looking for cement and concrete, for example, after water, this is called the second commodity. There is a huge demand for cement and concrete, and at the moment there is a huge demand for sustainable materials with a low carbon footprint. And that's very important, because if you can interest investors for this solution, then you will not have the possibility to realize this solution for asbestos. So you have to develop an interesting business case for investors. The environmental profits were examined by one of the specialized bureaus in the Netherlands. And then you can look to the replacements for materials using our calcium silicate slurry and compare that to, for example, the ingredients in cement, in talc, in calcium carbonate or titanium dioxide. And then I'm mentioning the paint industry. And you see there's a huge difference. And there's also, and at the same time, this is an interesting difference for buyers of these raw materials. But what I want to emphasize today is that we can solve the problem that asbestos cement poses to the world, but we can't do that alone. We need you, and we need policymakers, and we need investors to do so. As Asbeter AC Minerals, we intend to build a flagship plant in the Netherlands, and then deliver the technology by licensing to other projects in other countries. So we need a technology, we need business communities, we need the government with their policy, and we need investors. And then together we have a very important solution to get rid of these asbestos fibers and the risks we are facing every day in our livelihood. And at the same time, we are contributing to the circular economy in an important way. Is this also a possibility for the UK, for Ireland, for, I don't know where you all are from, but for other countries outside the Netherlands? And of course it is. We are in the middle of an application project in which we research all these topics per country and per consortium that is interesting to start such a business in their own country. And that is going from what is the amount of asbestos that still has to be removed to what are the current landfill prices, what is the availability of landfilling, how interested is the market in buying your sustainable products, what is the time you need for permits, environmental permits, permits to build your plant, what is the way to transfer our certification and end-of-waste status in the other countries, etc., etc. And this could be also interesting for you, for possible cooperations. You see, it starts all with exploring the possibilities, the same we did 5 years ago. So from research, analyzing and demonstration, we are going up to build a full-scale industrial plant. You see here a view of our current demonstration plant, but we have to go to a plant for processing 75,000 tons of asbestos cement a year. And looking at the amount of asbestos cement that still has to be removed in the Netherlands, we see a volume of more than 2 million tons asbestos cement. And if we engineer the plant for a capacity of 75,000 tons a year, you will realize that we need 25 to 30 years to get rid of all the material. Does that mean that all the asbestos cement cannot be removed? in the meantime. No, that's not what we intend. We intend to start a regional intermediate storage. It's in line with a interesting advice our Ministry of Environmental Affairs received already in 2018, which says, well, government, you have to start, if you want to stop landfilling asbestos cement, then start with regional storage. And in the meantime, take 10 years to find a solution. Well, you can understand, like we did, that our government didn't pick up that idea, but now they can. There is a solution coming to the market. There is a processing plant that will be built, so they can start regional intermediate storage. And we worked it out in a concept with an engineering company, because how can you safely store that material for a few years? Well, we developed safe airtight packaging, we tested it, and it has to be stronger than the packaging which is used now, because you have to lift it several times. But we expect that this kind of packaging will be used directly at the demolition site. And then it will be brought to the intermediate storage facilities, which you see below. It's only a concept. People can engineer it or design it to their own opinion. But it will be brought to closed intermediate storage, where we will pick it up in ISO containers, in closed ISO containers, to bring it to the plant for processing. That means that no material have to wait till there is a possibility for processing. For us, it means that we don't have 60 people waiting with their material to bring to the plant. And for our government, it will assure them that it's safely stored till it will be processed. This is the location we are researching now for engineering our closed the processing plant. It's in Moerdijk. It's the southwest of the Netherlands, and we need a service of around 2.53 hectare. In the engineering of the pre-treatment, I told you it's a closed system, but how does a closed system look like? We all know waste handling, and these are all open belts we are used to, but that's not the case. You can't use them in processing asbestos cement. Everything has to be closed, and it has to and we have to add a dedusting system to it. And of course, it's all in a containment, because this is the moment that there could be any dust coming if you are opening the installation. We will process from control room, so it's not necessary that people go in their overpressure suit only if we have maintenance issues. But in fact, everything will be organized from the control room. And in the right above, you see that after the pre-treatment, it's we have then small particles of around 12 millimeter. Then it's going to the wet process, and you are aware of the fact that if it's a wet process, then we have set a important safety step, of course. Then we go on with the alkaline environment. Other risks, of course, you have to make an inventory of the possible risks, and we did so. Other technological risks, how can you mitigate them? And we all did it for technological and for economical risks. It's also important to discuss this with your possible consortium, with your interested investors, that we made an inventory of possible risks, but that we at the same time worked at the mitigation measures. I think at this moment, if you would ask me what I see as the biggest risk at this moment, I think it's changing the culture. It's not a technological risk. In fact, it's rather easy. Is it a financial risk? Well, there is a good business case. Is it commercial risk? Same answer. It's there's a huge market for sustainable end products, but I think changing the culture is the real challenge, because we all are aware of the fact that asbestos is a problem. It's a danger, and it is. And it will take some time and some effort that we will realize together, well, there's coming a real solution to deal with asbestos cement. And I think that's the biggest challenge at the moment. What we see for the future is that before 2030, that we will sell 5 licenses in Europe and beyond. And after 2030, this will go on. We are really willing to solve this problem. But of course, we can't do this alone. We need other parties to do this in all the other countries that are facing the same asbestos problems as we are facing. This is not a joke. And this slide, it's a question. It's a kind of idea or dream, or how shall I explain it? But we were out of the box thinking about the possibility of processing from a ship. If you have a long coastline, and it's hard to decide where you will build a plant, then, to our opinion, there's also a possibility to do it by ship, and go from place to process the material and bring your end products to the market. It's not more than an idea and a kind of out-of-the-box thinking, but maybe you like the idea and will go on with this thinking. Well, I will end with introducing at the heart of our management team who are dedicated to solve the asbestos problem and really build the first AC Minerals plant in the Netherlands and bring all these raw materials back to the market. One thing is then for sure, we get rid of the asbestos fibers in a rather simple but also genius solution in that alkaline process. And this is my last slide, and we really invite you to join us and to visit us in the Netherlands if you like to see and to know more about this. Thank you.